The recognition of actions in videos represents one of the most important current topics in artificial intelligence and computer vision. Knowing what action is being carried out in a live video has many possibilities. From the creation of smart ambience to the development of security systems. We present an innovative model that combines several recurrent networks with processed data from different techniques. Image feature extraction, object detection, and people skeletons. Traditional video action recognition systems typically use two different techniques, depending on whether they process frame by frame or full video sequences. While full video sequence processing methods use classification neural networks with 3D convolutions, frame-based methods extract sequences of consecutive frame features and then perform the classification either through some function applied to the sequence of feature vectors, such as the mean, or through recurrent type networks, such as LSTM. In our work, we have found that the information coming from feature extraction networks does not take into account certain aspects related to the nature of the scene. Although the network is able to learn to recognize salient points in the image, certain semantic aspects may not be learned. For example, if an image shows a bottle and a person, and if the bottle is located on a person's limb, it is possible that the person is drinking. In the same way, the coordinates of the skeletons of two people who are intertwined help us to understand that these people are carrying out a joint action. Such an action may be to assist in walking. A network that recognizes action specializes in such classification, but is not as effective at detecting the skeletons of people as others, such as OpenPose. In this sense, object detection networks are specialized, and can identify a wide variety of items used in everyday life, such as books, cups, chairs or televisions. For the approach we have followed, we process each of the n frames of a video sequence. Each of the frames is fed into an inception, V3, neural network, from which we extract the feature vector prior to classification. This is the normal technique used in the LRCN method. We produce a sequence of feature vectors. This sequence is fed as a sliding window into an LSTM network, the output of which is a vector of the same dimensions as that of a single frame. Additionally, in our case, we search for the coordinates of the most prominent person, or two people, in the scene using OpenPose. This step allows us to generate a sequence of vectors of people's positions, normalized along the sequence. This sequence is also fed into an LSTM, analyzing the entire sequence and producing a single output vector. Using a YOLO neural network, we extract the coordinates of all the objects appearing in the scene. This allows us to explore the relationship between these objects and the people. A sequence of vectors of the positions of the objects is also produced. This output is also processed in a LSTM. Finally, the outputs of the three LSTMs are connected to a fully connected layer, and a classification layer, adding certain dropout and regularization parameters. An additional test carried out has been to replace the last dense connection layer by an SVM classifier. Unlike other techniques, the system can be implemented in real time using sliding windows. We have evaluated the method against the STARE dataset, a dataset consisting of more than 64,000 videos. The results show that this model improves the accuracy obtained by the LRCN technique, but also by other existing techniques, such as 3D convolution-based classifiers, or the two streams method, which also considers the optical flow of the video. In addition, we have seen that the method performed better using SVM instead of neural network-based classifiers. The best results with neural networks were obtained with a single hidden layer. These results show that the model can be used in a variety of applications, including real-time systems, facilitating its deployment through the use of standard RGB cameras.